In this video, we are going to learn how to use MATLAB to perform linear regression and confidence interval estimation. You can do this on the command line, but it's probably easier to start by editing a new .m file or script so that you can edit as you make mistakes or changes. So first thing we need to do is add in our data. Here we have our x set. X is going to be 7.5, 5, 4, 6, 5, and 8. This is the data set that we used for the comparison between GPA and sleep in the earlier video. Okay, and our sleep values then are going to be 3.70, 3.10, 3.32, 2.98, and 3.68. Okay, there are our data. Next, we have to choose a confidence level. I'm going to call this conflev and set it equal to 0.80. Next, we need the number of data points, calling it cleverly n, and we will do that of our y array. Now we need both the means, so we have x bar and y bar. Next, we're going to need the sum of the squared differences between x and x bar. We'll call that sxx equals, I know there are easier ways to do transposes, but this way makes it very explicit. With that, then we need the estimated best slope of the best fit line and the estimated intercept. So the slope is beta 1, and that is going to be x minus x bar times the transpose of y minus y bar divided by sxx. And that one we probably want to see, so we won't put a semicolon. And then beta naught equals y bar minus beta 1 times x bar. And we probably want to see that one as well. It might be useful to have the fitted data, so we'll do y fit. That's going to equal beta 0 plus beta 1 times x. Okay, now we need the sum of the squared residuals, SSE, and that is going to be equal to y minus y fit times the transpose of y minus y fit, and that will give us the sum of the squared residuals. And then we need the root mean squared residual, S sub e, that's going to be the square root SSE divided by n minus 2, and we probably want to see the root mean squared residual, so we won't put a semicolon there either. Then we want the sample standard error for beta naught and beta 1, so that's S is SE times the square root of 1 over n plus x bar squared by sxx. Okay, and S beta 1 is just going to be SE divided by the square root of sxx. Okay, now we need the t factor, and because the t factor in MATLAB is the one-sided test, we need the two-sided test, so we have to massage a little bit. So we'll call it the student t is going to equal t inverse t of parentheses 1 minus 0.5 times 1 minus conf lev. That will give us the correct range for the two-sided test, and then n minus 2 for the t value. Okay, then we need the confidence interval, or the half confidence intervals, the lambdas for beta 1 and beta 2. And these follow the definitions you've seen before, the t times the standard error in beta naught and beta 1. Okay, now some things for some plotting. Let's create a data set for the plot, so we'll do range. And then we'll generate an array of x values for the plotting. And likewise, we will first do the best fit line, which is just beta naught plus beta 1 times. So that gives us our data sets for plotting. Now we want our sy hat and our sy for our functional range and our data range, our observational range. So sy hat is going to equal se times square root of 1 over n plus x plot minus x bar with x plot minus x bar divided by sxx. And that should give us our sy hat and lambda y hat. Will just be that times t. And likewise for sy. And in this case, I'm going to save myself just a touch of typing by copying and pasting that and adding a 1 in there so that I've got that. And since I'm lazy, I'm just going to copy and paste that one as well and just delete some hats. Okay, so we have those. Now it's time to do some plotting. We want to plot the data points, the best fit line, and the functional and observational bounds on this. So we'll do figure 1. We will plot x comma y, comma. We will put x's in there for the values on that. So since we want everything else there, we're going to put the other values as well. And these ones, I'm just going to copy and paste what we're going to do for the rest of these, because there's not too much here of educational interest, but there is quite a bit in terms of just using MATLAB. So we turn the hold on so we can do multiple plots. First, we have the x plot and the y plot, which is our best fit line. And then we have our x plot and y plot plus lambda hat. So this is our functional high side. And then x plot and y plot minus y hat, which is our functional low side. And we're doing them as blue dashed lines. Then we'll do y plot plus lambda y as dashed magenta lines. And minus lambda y is just magenta lines. So that's our observational boundaries. Then the usual fancy things, the dean of students, hours of sleep, GPA, and this is basically sometimes the legend doesn't appear where you want it to be, so we have a little bit of fixing the legend here, and then there we have the remainder of that. Okay, so now we have this, we probably ought to save it. Line fitter script. And then let's give it a run and see what happens. So obviously we had some problems in there. And so we're going to have to figure out line 21, column 57. So we will do a little checking and see if we can figure out what we did wrong. And try running it again, see what we get this time. Okay, this time we got all of the numbers, and there you can see the plot very nicely as we go through.